Hello, I'm Joe, and this is a quick introduction to VTOS Scan, an embedded test tool for hardware interface testing. Kozio provides tools for design engineering provide an interactive GUI for fast loading of embedded IPs, simple test setup and configuration that provide automatic calibration and device adding. It also includes a powerful scripting environment for troubleshooting. For automated testing, you have the same ability. The small embedded IPs can be loaded very quickly with dynamic runtime configuration for fast validation and device programming. Also included is powerful scripting for test automation. VTOS Scan is a standalone application that doesn't require any bootloaders or operating system, so you get pre-OS testing. It runs from on-chip memory, so it's very fast, has very fast execution. It also provides stable, software-driven bus scans and device testing. Even if a fault is encountered, the VTOS scan firmware will continue to run without rebooting or reloading the firmware. It also provides auto configuration from Golden boards. I'd now like to show you a quick demonstration of the GUI in action. So I have it running on my PC. I have a BeagleBone ARM Cortex-A8 sitting on my desktop. I've loaded the VTOS scan object code using an SD card, and I'm communicating over a serial port. I'll now switch to running the VTOS scan GUI. So to provide a quick overview, you have a number of options to create a new configuration, open a saved one, save it as a different name, and you can actually export your configuration to a Kozio script file or an NI test stand sequence. You also have settings, which provides the ability to specify fixtures and if you want to save your console output. Lastly, you can have the tools of connecting, which will connect from the PC to the firmware running on the DOT. Then you can run these commands to test them out and validate it before you export it for your automated test, and then disconnect. Once connected, you can see the PC, the versions of the PC and DOT firmware. So just to quickly give you a quick overview of creating a new configuration, I'm going to go ahead and select the BeagleBone Sitar AM3358. Then you can see you have various things where you can actually name your particular devices in the tree. You can select a pin configuration file, which will set up the pin muxing. You can do pre and post actions. Pre and post actions these are all of the actions available. You can just double click on them, add a number of them. For each one that you add, you can then add configuration data, and you can alter the order by using these arrow keys or remove actions from that list. And you can see we have a number of actions for setting and clearing memory, doing delays, GPIO signaling, I2C read, write, and dump, memory read, write, and dump, running any of the Kozio script commands, and then some of the UART configure, input, and get C. We find that these are useful for if a device requires a GPIO signal or some kind of pre-setup or post-setup, you can use these actions to complete those. In addition, for any given group, you can select a particular channel and add the different tests that are associated with each type or channel type. The base product supports GPIO, I2C, SPI, and UART. For any given test, you can then set up the configuration parameters for that test. In addition, for certain buses like I2C, you can actually connect to the target. And once connected, you can do things like run a scan, or you can run and scan and add, which will automatically add the devices discovered. And that provides a nice, easy way to add devices for configuration. When you're ready, you can then run that particular test. And you can see here I've automatically added devices found on I2C bus 0 and automatically have a test that verifies that the device is there. I can then save this configuration and export it to test stand or the Kozio script for automatic inclusion. Each group provides the capability to add the test, which changes based on the particular device that you're adding for that particular type of bus like UART, SPI, I2C, or GPIO. That, in a nutshell, is a quick overview of the VTOS Scan product in action. If you would like more information on our hardware interface testing, please go to Kozio.com VTOS Scan, where you can find a datasheet, user manual, and other videos describing various how-to capabilities of the tool. Thank you. We hope you found this overview valuable.